Okay, so yesterday we used the quadratic formula to solve quadratic equations. When I say quadratic equations, I mean things that have x squareds and x's and numbers. So what we did yesterday, we got x squareds, x's, numbers all the same side to make the equation equal 0. And once the equation equaled 0, in our old days, we used to, in Algebra 1 and earlier in Algebra 2, try to factor and get solutions that way. But yesterday, we dealt largely with ones that couldn't factor. So we used the quadratic formula to solve those. The number in front of x squared we called a, the number in front of x we called b, the regular old number we called c. And when we wanted to solve for x, we got usually two answers by running this formula. The opposite of b could add or subtract a root, and the root could do all sorts of different things. The root had b squared minus 4ac under there, and it was all on top of 2a. The part that's under the root, because it can do some different things, has been given a name over time by math people, and that name is the discriminant. So today when I talk about the discriminant, I'm just talking about this b squared minus 4ac part that's under that radical sign. So yesterday we saw a few things happen. Sometimes we were rooting negative numbers. When we rooted negative numbers, we'd have to enter the imaginary complex world of i's. So if this number under here is a negative, we got a bunch of I complex imaginary answers. Sometimes yesterday we saw the number under the root sign be positive. And when you do a root of a positive number, there's two perfectly valid square roots. We take them both, we go after that, but we just were able to stick with real numbers, good old-fashioned numbers. I don't know if this happened yesterday, but it's also possible to get 0 there. So this discriminant could be positive, could be negative, could be 0. So the beginning part of the homework today is going to have you work on that idea and just have you tell what types of answers there would be and how many answers there would be. They don't care what the answers are. They don't want you to get the answers. They don't want you to run the full quadratic formula today. To start the homework, they just want you to look at the b squared minus 4ac part and see what's going on. And as I said a minute ago, if that b squared minus 4ac thing, let me do this one. If the b squared minus 4ac, if the discriminant is positive, that's going to give you two real answers. And that happened a lot yesterday. If the discriminant turns out negative, that would have two complex answers, things with i's in them. And that happened a lot yesterday. And if somehow that turned out to be 0 for the discriminant, that would have one real answer. Because if this were 0, the square root of 0 is 0. Adding 0 is the same result as subtracting 0. We wouldn't have two options. You'd only have the one option. 0 would eliminate all of this formula and just have negative b left on top of 2a. There's only one choice there. So the homework might say to you something like x squared plus 8x minus 5 equals 0. Let me go plus 5 there. And say, what type of answers does that have? Well, you would do just the discriminant part. Take b squared, 8 squared is 64, minus 4 times a times c. So a is 1, b is 8, c is 5. So when we did b squared, that's 64 minus 4 times a times c, 4 times 1 times 5 is 20. 64 minus 20 is going to be a positive number. We don't even care what the number is. It happens to be 44. It doesn't even matter. We just care that that's positive. If we get a positive result, they just want us to say there would be two real answers. And they don't care what those answers are. Just say there would be two real answers. If this had been something like 64 minus 80, let me change that to a 20. So if the original problem had a 20, and we're 64 minus 80. 64 minus 80 is negative. If we get a negative discriminant, we would instead say there's two complex answers. Instead of two real answers, we'd say two complex. If I changed this to like a 16, I'd be going 64 minus 64, which is exactly 0. If I did that, now there's one real answer. Okay, so to summarize again, just do b squared minus 4ac. The b is the number with the x, the a is the number with the x squared, c is the other number. Make sure you're equal 0 before you start. But do b squared minus 4ac. If it equals 0 exactly, say 1 real. If it's positive, say 2 real. If it's negative, say 2 complex. That's what the first part of the homework will be. Second part of the homework is going to do a little bit of math trivia. So it's just a math trivia fact. When you get these two answers from the quadratic formula, usually two answers, if you add the answers together, the sum of the solutions will always turn out to be a fraction that involves the opposite of b on top of a. The product will always end up being c over a. It just happens every time. If you don't believe me, I could prove it to you in person another time, but I'd say just take it by faith. It's just true. The book's not lying to you, neither am I. So for a problem like this, you can't judge anything until these problems equal 0. So if they give you something that's out of order, not equal 0, make it equal 0. 3x squared can sit, plus 4 can sit. The positive 12x, we can subtract 12x to make that equal 0. The a would be the 3, because a is always with x squared. B is negative 12, because it's always with the x. C is 4, because it's always the plain old number. The second part of the homework is going to ask you, once things have been made equal 0, to just say, what is the sum of the answers? They don't care what the answers are still. They just want to know, if we got answers, what would their sum be? So we just use this fact. The sum is always the opposite of b. So the opposite of negative 12 is positive 12, divided by a. And if we divide by 3, the sum of the answers would be 4. So maybe they're like 3 and 1, maybe it's 2 and 2, maybe it's 4 and 0, maybe it's 1 1/2, 2 1/2. We don't care what they are. Whatever the answer might have been, they would add up to 4, and that's all they want us to hunt. The product would be a different fraction. To find the product, we put c over a. So 4 over 3 is the product. So whatever the answers might be, if we multiplied them, it would be 4/3. And for the millionth time already, they don't care what the answers are. Third part of the homework is going to use that idea, that trivia fact, in a different way, inside out. If I give you the equation, you can come up with sum and product. That means if I gave you sum and product, you should be able to reverse field and come up with the equation. In an earlier section, you were asked to come up with an equation if you were given certain solutions. So that way of doing it is still valid. And I'll talk about that in a second, but what they want you to do is use the sum and the product to do this today, so we're just going to do what the directions tell us to do. So for this, if they say the solutions to the equation are negative 4, which is like it's over 1, and 5/3, what we would want to do is figure out what is their sum. Sum means add. If we add these, adding fractions needs a common denominator, so put this over 3, changes this to 12. Negative 12, if it adds 5, would be negative 7/3. If we add these answers together, we would get negative 7/3. Product means multiply. Just multiply those answers straight across, and we would get negative 20/3. And then just use our two trivia facts of the day to figure out what a, b, and c are. The a is going to be the bottom of both fractions. So these already have a common denominator. If they did not have a common denominator, we'd have to force them into that. Okay? We need the a to be the bottom of both fractions. So we know from looking at both of these, a would be 3, but make sure those agree with common denominators before we do anything else. The top of the product fraction tells us c. So negative 20 is c. The top of the sum fraction gives us the opposite of b. So this sum fraction would tell us that the b is actually positive 7. And then we can write our equation. A goes with x squared. The b goes with x. The c stands alone. And every equation is going to equal 0. This would be an equation that has a pair of answers that we never figured out what they were, and we didn't care what they were. But those two answers would have a sum of negative 7/3. They'd have a product of negative 20/3. And I take that back. We did know the answer. were. I misspoke that time. But these answers would come from that equation because they had the right kind of sum and product. The final two are the same, we're based still on the same idea, okay? And this is a lesson we did before. Last chapter, sometimes you were given solutions and you were asked to write an equation. And the way we would have done it for this, if this is an answer, I'd have gone x. This is an answer, I'll do another factor with another x, and we switched all the signs. -2, minus root 5. This would be -2, plus root 5, because we're switching all the signs. We made that equal 0, and this was a homework where half the problems I made you foil that out, and you probably got a little grouchy, and half the problems I let you just stay there, and you were probably kind of happy, because foiling this out, 3 terms times 3 terms would make 9 terms. It would be a big giant thing before it would shrink. That's maybe a tough way to do that. If we tried to do that with this, it would be an even tougher way to do that. I don't think you want to foil out stuff with x minus this and x minus that and get into this big foiling extravaganza with fractions. That would be tough. It could be done. It's correct to try it that way, but it's going to be rough. So we're going to discard that way of doing it today. Just do what the book wants us to do, is figure out the sum by adding answers together. These answers added together would be 4 because these root 5s that are opposites would vanish when we add. The product is slightly challenging because the product we're going to have to foil 2 terms times 2 terms and get 4 terms. However, that's a whole lot better than foiling 3 terms and 3 terms to get 9 terms. So if we foil these two, this is a positive mess, and we catch a break because that's a negative mess. So we don't care what the positive and negative messes even are, they're just going to nullify each other. So when we multiply these, we really are worried about a 4 minus a regular 5. Root 5 times root 5 is regular 5. 4 minus 5 would get us -1. And then we're trying to use our trivia question. To use our trivia facts, we need these both to be fractions, we need them to have common denominators. And they do. These can both be written over 1s, and they have a common denominator. And then eyeball things. The A is what's on the bottom of both. So these 1s are A's. The C is from the product. So -1 is the C. The B is the opposite of the sums taught. So the opposite of this would be a -4. And then just write an equation. A goes with x squared, and I don't want to write the 1. The B goes with x. The C is there, and we're going to make that equal 0. If you did want to try to foil that out to check it, it'll get you there. It's going to get you that equation. But I don't really have any interest in doing that. One more with the fractions, just do the same thing. They're giving you the answers, they're wanting an equation. So what I would suggest is figure out the sum. Add these up. Okay, if we go 2 and 2, that's 4. The roots, positive and negative, would eliminate. The bottoms would be 2. And even though it's tempting to immediately simplify, I might suggest just let it go. Because ultimately, to use our trivia question of the day, we need these to be fractions. We need common denominators. So maybe don't take it out of fraction form too fast, because it might be a good thing that it is a fraction. The product, we want to multiply these two things. So for the product, bottom times bottom makes a 4. On top, it's the same foiling we did a minute ago, so I did a little bit of a teacher cheat. I made the same problem repeat. It saves me a little bit of foiling time. But we foiled this a minute ago and got -1. Nothing has changed. If we foil this now, we're getting -1. But we need to create those two fractions, one for sum, one for product. So we want these to both be fractions. We need the fractions to have a common denominator. So with 2 and 4, I'm going to go with 4. This would become 8/4 because I'm multiplying by 2. And then we're looking to use our trivia question. The A's are going to come from the bottoms of both. We need to have agreement, and we just force that agreement. The A's are 4s. So this answer, I'll squeeze up here because there's better space. It'll equal 0. It's 4x squared because the A was 4. The C is always the top of the product. The top of the product, the C is -1. So I'm going to put on there -1 in that position. The b comes from the top of the sum, but it's the opposite. So we just made this 8. The b would be negative 8. So we go negative 8 there, and that's what we're up to today. Let me grab my book. So the 8-3 homework, we're skipping multiples of 3. The first 15 is like what I did first, where you do the discriminant and you just say 1 real answer, 2 real answers, 2 complex answers. There's 15 of those, but we skipped the 3, so 10 of them. From 16 to 27, it's like what I did right here. They give you an equation, make sure it's equal 0, and you just write down the sum and the product using our 2 trivia facts of the day. Just by test day, you have to have memorized what fraction is which for sum and product. 28 to 31 is more like these, but they give you more of an advantage than I did. Here, I made you add and multiply to make the sum and product. They're going to start off just giving you the sum and the product, and they'll want an equation using our trivia fact that goes to 31. 32 to the end is more like what I was doing on these 3, where you'll add to figure out the sum yourself, you'll multiply to figure out the product yourself, make them have common denominators, and that lets you identify ABC. But that game that I did 3 up here at the end, that runs from 32 to 55 all the way to the end of the line. So that's that.